This video is for section 6.2, solving systems using substitution. Our goal is that we can obviously use substitution to solve systems of equations. Now this is going to branch off of what we did on the previous section. Remember in 6.1 we learned how to find the intersection point using graphing. Sometimes graphing is not ideal, so another method is called the substitution method. The first thing that we're going to do is solve one of the equations for one of the variables, which means get a variable by itself. So you know, like y equals 2x plus 1. The y is by itself. That's ideal. Now, once you do that, you're going to substitute that expression for the variable into another equation. So that means you're going to take the 2x plus 1 and plug it in for the y in the other equation. Now that's going to make more sense when we actually do example 1. So feel free to pause here if you need to catch up on these bullet points. Let's take a look at what this actually means. We're going to solve this system. Remember, solving a system just means finding where these two lines cross paths or intersect. And because y equals 3x is by itself, you know, do you see the y? It's by itself already. It's isolated. We can substitute the 3x in for the y in the second equation. So here we have x plus y equals negative 32. What we're going to do is take the 3x and plug it in for the y in the other equation. So it's completely going to take its spot. The y is going to go away altogether. So we have the 3x right here, and then the rest comes down. The only thing that's changing is that the 3x is replacing the y. And the whole point of that is so that the variables are the same. As you can see, we have a 1x and a 3x. We can easily combine them. That's 4x equals negative 32, and you definitely know how to do a one-step. You divide both the sides by 4, and you get x equals negative 8. Now, you're not done yet, but you are about halfway there. So feel free to rewind that if you need to, or pause. Now, we just found the x-coordinate, and you know that when you have a coordinate, there's an x value and there's a y value. We just found the x, and I'm guessing that you're guessing right now that in order to find the y, you plug in the x, and you're right. Now, you don't have to choose one specific equation. You can choose either of them, and they will work, whatever one you like better. It looks like I chose the first equation. It really doesn't matter. So step 2 is to substitute our answer, negative 8, in for either equation and then solve for y. So we have y equals 3x. Now we know that negative 8 is x. So you're going to take that negative 8 and put it in for the x. So we have y equals 3 times negative 8, and that equals negative 24. So there's our y value. And the last step is write the coordinate. So the solution is negative 8, comma, negative 24. And looking at those numbers, I'm hoping that you're grateful that we did not have to graph that, because that would be really far down in the negative. That would be in the third quadrant. Now I'd like to show you how to check your answer, because I know that you would like to know how. And the way that you check is you just plug in your coordinates for both equations. And if they work for both, then you know that that is the answer. Alright, we can plug in the coordinate for the first equation. We have negative 24 equals question mark, we're not sure, 3 times negative 8. Yes, negative 24 equals negative 24. It works. Now let's try the next equation, negative 8 plus negative 24. Adding two negatives means you're getting more negative, and yes, it equals negative 32. So it works, and we are complete with the first example. Now let's use an application problem. In example 2, we have a snack bar sells 2 sizes of snack packs. A large snack pack is $5, a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many snack packs did the snack bar sell? So how many of each type, the small and the large? Well, as you can see, there are 2 different sizes, so we should definitely define our variables. So how about we let x be the number of large $5 snack packs, and y be the number of small $3 snack packs. Step 1, we want to write the system of equations. So first off, they told us that they sold 60 snack packs in one day. So in order to find the total, you just add the pieces. So x plus y equals 60. There's our first equation. Now our second equation is going to involve the prices. The large snack packs are $5. So we multiply, that makes it quicker. And the small snack packs are $3, so we also multiply. And they totaled $220. So the first equation was about the number of snack packs, and the second equation is about the cost. And you can feel free to write that down if you want. That's typically how it is. They don't have them mixed up. So, and this is the cost. Lovely. Now we're going to solve one of the equations for a variable, and the top equation is much easier to do so. So what I'm going to do is solve first equation for y, and that just means subtract x from both sides. So x plus y equals 60, and we're going to subtract x to the other side, so y equals 60 minus x. Now, the y is by itself, which is really good. We are going to now take that 60 minus x, and that is going to be substituted in for the y in the second equation. If you deal with the first, you want to deal with the second. So now that is going to be shown like this. And I'm going to move up to the top now. Step 3, we're going to have 5x plus 3y, but instead of putting the y there, I'm going to put the 60 minus x, and the reason why is because 60 minus x equals y, so you can just substitute in, and it equals 220. The good thing is now they are all like terms, all x's, no y's. We're going to distribute that 3 to both, so that means we have 180 minus 3x, and the rest comes down. You can see that there's a 5x and a minus 3x. That equals 2x plus 180 equals 220. We have a nice two-step, and you guys know how to do that. Minus 180 to both sides. 2x equals 40. One step, divide by 2. X equals 20. So we are mostly there. We know that the snack packs that were large sold at there were 20 total large snack packs. Now we got to figure out how many small ones. Now, remember, in the previous problem, we substituted in the x value, and that's exactly what we're going to do now. So, let's see, step 4. The first equation is much easier. I think you would agree with me. The x plus y equals 60, so I'm going to be plugging that in. So x plus y equals 60, taking the 20, putting it right there, substituting in 20 plus y equals 60, one step, subtract 20 from both sides, and we find out that y equals 40. So the system solution is 20, 40. And what that means is the snack bar sold 40 small snack packs and 20 large snack packs. Now let's take a look at some special cases. These are the exact same special cases that we talked about in the first section when we were graphing. The first one is if we get a true statement, then we're going to have infinitely many solutions. Now, remember, infinitely many means that we have the exact same line. So there's the first line and the same line on top of it. So write that down. And a couple examples of true statements are 0 equals 0, 2 equals 2, etc. As you may have noticed, the variables are canceled out. So make sure you write that down. That's really, really important. Variables will cancel out. They will go away, aka disappear or be eliminated. Now, if you get a false statement such as 8 equals 2 or -5 equals +5, then you're going to have no solution. And when that happens, there are parallel lines. And you know that parallel lines do not intersect. Now let's take a look at what these look like in examples. How many solutions does each system have? Well, remember, it's really, really ideal for us to have the variables by themselves, and we have the x by itself. So what we're going to do is take the -2y plus 4, and we're going to substitute it in for the x. So instead of writing the x, I'm going to write -2y plus 4 in its spot, plus 7y equals 14. We're going to distribute the 3.5 in front, like usual, and that's going to give us -7y plus 14 plus 7y equals 14. And you can see -7y plus 7y, they cancel each other out. So we have 14 equals 14. That is a true statement. So if you get a true statement, you know you will have infinitely many solutions. AKA every single point on the line is a solution of both equations. Okay, now let's take a look at the part B. We have y equals 3x minus 11, y minus 3x equals -13. The y is by itself in the first equation, so circle the 3x minus 11. We're going to plug that in for the y in the second equation. So let's start off with the second equation as is. Now in the next line, instead of writing y, I'm going to write 3x minus 11, and then bring the rest of the equation down. Now we have 3x minus 3x, those cancel out, and we have a -11 equals a -13. That is not true, that's a false statement. Therefore, the variables are gone, and we have a false statement, so the system has no solution, and that means that these lines are parallel to each other. Okay, you got a taste of how substitution works. I know that this is confusing, so that's why I am practicing these problems for 2 days instead of 1. Make sure you have completed the lesson check from section 6.1, and if you feel like you could try section 6.2 lesson check, feel free. If not, you can wait until we do problems together during class.